Hey geometry friends, welcome to the last part of the first section of chapter 4 that we started the other day. This is the end of section 4.1 where we start talking about what does it mean for shapes to be congruent. And we eventually said that as long as these figures have the same size and the same shape, then they are going to be congruent. And once they are congruent, then we know that all the corresponding sides and all the corresponding angles are also congruent as long as they match up and correspond. So with triangles, that means we had 3 pairs of sides and 3 pairs of angles that were also congruent. And then we learned how we had to write the angles and write the sides, and overall, how do you write congruent triangles? Make sure the letters are always in order. And we went to that, and we got to the end, and we ended up with this last theorem here, which basically said if you have 2 triangles, and in those 2 triangles, if you know, for example, that these 2 angles are congruent, and you know that these 2 angles are congruent, what must you know about the last pair of angles? And you can plug in numbers to check and see, but it will be true that these 2 angles will also have to be congruent because the first 2 pairs are congruent. It just has to be. They all add up to 180, and if they're congruent sets, then that last set of yellow angles will also be congruent. Since those were the third pair of angles, we call this one the third angle theorem. The third angle theorem officially says, write this one down in your notes. If 2 angles in one triangle, the red and the green, are congruent to 2 angles in another triangle, the other red and the green, then the 2 yellow angles have to be congruent. And that's called the third angles theorem. That's going to be helpful when we talk about congruent triangles because we're going to need to show that all the angles are congruent, but we can stop at just 2. If you know that 2 pairs of angles are congruent, then you can stop because you can already show right away by this theorem that the third set will also be congruent. Okay, we're talking a lot about proving triangles congruent. So here we go. Let's try a proof. We will see a lot of proofs in this chapter, but they're so good. They're ones that we will really get, so I'm happy for them. Here we go. Let's start with our given. And there's our proof, and we need a diagram. Here's our diagram for today, folks. All right, we have these 2 triangles that face each other at the points like that. And we have A to D, and we have B to E. And what else do we have? Oh, that sounds good. And we have C right here in the middle. And there we go. So go ahead and draw that diagram in your notes. Label everything on the given, and we'll see what we can do. All right, I'm going to probably need a little bit more room here. So what I'll do is I'll probably start this on another page. There we go, statements. And I'll go back to that previous page so we can refer back to the picture. All right, step 1 is always the given. So let me copy down that given. That was AD bisects BE. And also it was, I believe, BE bisects AD. So they basically bisect each other. So as you're writing this, think in the back of your brain, what does that mean when lines bisect each other? What does that do to them? And vice versa, we also have AB is congruent to DE. And finally, I think we have 1 pair of congruent angles. How about A is congruent to D? Okay. Good. That's a lot to have in the given. So what I would do now is why don't we use all that information? Let's mark our triangles. I think the key to success to proving these triangles congruent is to label and mark your diagrams. So first of all, what does it mean to bisect? When you bisect angles, when you bisect segments, it means you cut them in half, which means you'd create 2 congruent pieces or 2 congruent segments here. So if AD is bisecting BE, it means it's cutting BE in half. So therefore, BC and CE will be congruent. We'll write that down in a second. But let's just keep marking this up. How about BE is bisecting AD, which means it's cutting this one in half. Now I'm going to have to use 2 little hash marks here because I don't know if the whole segments are congruent. So for now, I'm just going to say those are with 2 little congruent symbols. Okay, so that's good. We dealt with the bisectingness. How about the last part? AB and DE. All right, that's going to need 3 of them. Cool. And then finally, angle A over here is congruent to angle D up here. All right, we've used all the given, we've marked up everything. And our goal is to prove congruent triangles. And to prove congruent triangles, you have to show 2 things. All 3 corresponding angles are congruent, all 3 pairs, and all 3 pairs of sides corresponding are congruent. You have to do all 3 of each, which means you basically have 6 things that you have to show congruent total. Well, look what you've got so far. Look at this. Let's just look at the sides. You have 1 pair shown congruent. You have another pair shown congruent. You have 3 pairs shown congruent. Yay, the sides are done. Now we have to do all the angles. Well, you were given angle A and angle D. Are there any other angles that you see here that are going to be congruent? Do you see that because of the way it's drawn, do you see that it forms an X in the middle? So whenever you have an X, that usually means you have vertical angles. So I can say that BCA and DCE are congruent because vertical angles are congruent. Now look, these are congruent. Remember we just learned up on the top of the page, if you know that 2 sets of angles in one triangle are congruent to 2 angles in the other triangle, what do you know about these third angles, this one and this one? They've also got to be congruent. And once we do that, you've got 3 angles, 3 sides, you are done. All right, let's write everything down. Now we marked sides congruent, but we really do have to write that down. We can't just assume that everyone knows that. So because AD bisects BE, that means this part here and this part here. So AD is bisecting BE, so BE is being cut in half. So BC is congruent to EC. Why? Well, because it bisects it. It just does. So that's the definition of a segment bisector. Good. But you notice that the other 2 segments bisect each other, so we can put that in the same statement. How about the fact that BE bisects AD? All right, that means it cuts AD in half. So AC and DC are also congruent. So we need to show all 3 pairs of congruent sides that correspond and all 3 pairs of corresponding angles. Okay, we have, let's see, a side here, a side here, and a side here. So I have all my sides. Great. Let's do angles. Well, I've got an angle here. And then remember we said the angle's right in the middle because they were vertical, right? The one's right around C. So we said BCA, but angle BCA is congruent to the other one on the right part of it. How about DCE? And the reason was because they're vertical angles. So not definition, but just the theorem. Either vertical angle theorem or vertical angles are congruent. Okay, we just found another pair of angles. We need 1 more pair. And this is where we can just say the brand new theorem that we learned, because the first 2 sets of angles are congruent, obviously the third pair have to be congruent. So we're going to say the blue ones that I marked up here. How about angle B and angle E are congruent? Why? The brand new theorem, ready? It's called the third angles theorem. That's all you have to put. You don't have to write it out. You can just use the title. Okay, now let's look and see what we got. We got 3 pairs of corresponding sides. Check. 3 pairs of corresponding angles. Check. We're done. We've got all 6. So our final statement is, let's make sure we get our triangles in the right order. Okay, let's follow what they say in the proof over here. ABC is congruent to, well, we can use the fact that it says DCE, or we can look at our diagram and just following all the little tick marks that we made, A to B to C, on the other triangle would be D to E to C. Now, why? Why? Well, because we showed everything congruent. So we can have 2 different ways that we can say this, folks. We can either say, well, by the definition of congruent triangles. You found all sets of sides and angles are congruent, therefore the triangles are congruent. Or we also used that cool new acronym CPCTC. Corresponding parts of congruent triangles are congruent. And that's generally how the proofs are going to start right now, is that in order to show congruent triangles, you're You're going to have to show all 3 sets of corresponding sides are congruent and all 3 sets of corresponding angles. Sometimes a lot of these are given to you in the given. Sometimes they're sort of inferred by bisecting. Sometimes there's vertical angles. Sometimes there's parallel lines. There's so many different ways that we can show this. So be creative and just know that's your goal. You need all 6 things to be congruent before you're done. Good, folks, and that's the end of section 4.1. Great job.